Okay, let's start with this starting slides of this course. So I'm just repeating some of the things that I have delivered in the previous lecture. So these are the course outlines. And the first one is explain the core concepts of NLP. So in these core concepts, we will see what are the different terms and definitions that people are using normally for this course of NLP. And then we will move on to this constituency and dependency parsing. I have skipped some of the chapters about n-gram language model, some statistical model. Why I skipped? Because you are computer science students, and if I will go with them, some of them are very much theoretical, uh, and some of them people are not using anymore in this course. So anyhow, I have skipped so that this course will be more interesting for you rather than you will be bored in future. And then the next, so here we will go with the constituency and dependency parsing. There are different types of parsing, but we will mainly go with constituency and dependency, which are popular one among other categories. And then we will go with the machine translation methods, how we can translate one language to another one. This constituency parsing, sorry, I'm going back. You maybe you have already studied a course that is called compiler construction. I don't know either you have studied or not, but if you have studied, then there is many things which are common between this concept of parsing and the course of compiler construction that you have studied there. So here parsing means because this is human language, a machine cannot understand human language until you will give him some mechanism. And that mechanism is parsing. You will teach your machine these two things, that there is a constituency parsing and there is a dependency parsing, and there are algorithms in it. There are different algorithms, but you will go maybe in this course with one or two, not more than that. But this CLO will give you the idea or the concept that how parsers, either it is for programming language, either it is for human language, normally deals with the text. For example, in programming languages, when you are writing C in and C out, or some input command or some output command and some mathematical statement, how that compiler is understanding, compiler is basically internally is parsing those statements. And you know that there are two types of parser. One is that which can parse the statement line by line, and other is which can parse the whole program at once. That is called compiler. Anyhow, so we will deal with these kinds of concepts here in this CLO. And then we will move on to machine translation. You already know what translation means. So we will see one or two algorithms here that how you can do this machine translation from one language to another one. Then we will quickly move on to machine learning and deep learning. We will not go into the details of this machine learning and deep learning because these are the separate courses in your curriculum. But I will try to present only those things which you have not studied on in those courses. But this is also a subfield of NLP, so that's why it is becoming again the part of this course. And then we will move on to information retrieval techniques. Information retrieval, search engines, Google search engines, Bingo, Mingo, there are different, huh? So how those search engines are working. So, and beside this, there can be, you can develop some system through which you can give some query and it will give you the information. So when you have systems like that, these are called information retrieval systems. And these information retrieval systems have totally a different mechanism. There are different models. Some are very much basic, some are very much statistical. So you will see how it will work. So here in this CLO, you will go with this information retrieval techniques. And then next CLO is about large language models. This is what the arena in which you are living, and you are dealing with different large language models around you, like Chat GPT, Llama, and there are different. You have 9 or 10 different names around you, and each model is expert in its has its own expertise. So you will see here what is the architecture of this large language models, what is the design of it, and how they are working. And then finally, this last CLO is about your project. It is not containing any content. I will give you some project at the end of this course, or maybe in the middle of the course, and then I will assess those projects under this CLO. Now moving next, course introduction. According to the CLOs, I have written something here that first we will go with the definitions. I must have to write here definitions anyhow. We will see some terms and definitions here. And then we will, these definitions and terms, and then we will go with the core concepts. For example, what is tokenization, stemming, lemmatization, what is parsing, different terms. We will go core concept, that what are the main topics involved in NLP. I will not discuss all, it is not easy for me to discuss all, but I will discuss only those which you are going to study in this course. Then I will go with the constituency and dependency parsing, then machine translation, machine deep learning, information, LLMs, etc. is written only just as a precautionary measure, that if I will cover some other topic, then I will cover it here. So this slide is also giving you the same concept that you have seen here. But these are the CLO statements, and these are our own chapter-wise or topic-wise headings. Now, what is the definition of NLP? So one thing is clear, that NLP is the branch of AI. NLP is the branch of AI, not from today, from the beginning. When AI emerged in the history, then at that time there was only two branches. One is robotics, other was expert system. Later on in the expert system, NLP becomes the branch of expert system. Or in some literature, some people were writing directly that NLP is one branch, other branch is robotics. But actually in expert system, you can say NLP was the first branch in expert system. Later on, then people come up with the idea of machine learning, and then machine learning becomes the... Initially, machine learning was the part of NLP, but later on, as the knowledge is increasing, then machine learning is becoming a branch of the NLP. And later on, deep learning comes, and then deep learning becomes the branch of also NLP. And as the NLP is a bigger branch, and machine learning and deep learning is sub-branches of NLP, but nowadays people are working more in machine learning and deep learning rather than NLP. So you can say it that NLP is something like a general physician, and then machine learning is something, for example, not general physician, but specific. maybe cardiologist, maybe a child specialist or something like that. So, so initially, so actually NLP is the branch of AI. And now what is the definition for this NLP? These are the lines which are giving you that idea that NLP enables machines or computers. It will make your machines able to understand human language, to interpret human language, to generate human language, and to reason with the human language. So these four words. If you will use only the word understand, it's enough. But if you want to go into the further details of the definition of the NLP, then you can add these words like you have here. So understanding meaning we are understanding. If I am speaking, you are understanding because you have the knowledge of this language. So this is what understand means. Understand the human language. Interpreting. If I will give you some topic, you can interpret that topic. Huh? Generating text, you can give some query and then the model can generate its response against that query. So that model is generating text. And reason, you are discussing some topic with the model and model is also discussing that topic with you. Okay, you can do that, you can do that, or something like that. Huh? So this is something reasoning, the concept of reasoning. So NLP is what? NLP is a branch of AI which makes your machines or computers able to understand, interpret, generate, and reason with the human language. With the human language. Oh, we are focusing on human language. The data would be in human language, either textual data, either speech data. So shortly, NLP is something through which machines can understand human language, through which machines can interpret human language, through which machines can generate text in human language. And NLP is something through which machines can reason using some human language. So I hope now you have the definition of NLP in your mind. But nowadays, modern NLP, if you will go into the old books of NLP, then you will see very much detail there, very much detailed concepts of linguistics there, theoretical linguistics also there. But nowadays, books of NLP are changing and they are focusing more on statistical approaches because these statistical approaches are giving more better results than the rule-based approaches. Rule-based approaches mean that if this, then this. If this, then this, huh? Something like that. So these are rules. No probability is involved. And statistical, you have different formulas in that that you have studied in stats. So if you are using those statistical theories or if you are using some probabilistic theories, that is what now modern NLP is dealing with. So now, but still in modern NLP, we have the concepts of linguistics, we have the concepts of statistics, we have the machine learning, we have the deep learning. We are writing these words again and again because nowadays people are understanding these two, two branches. Huh? So, so modern NLP is using these three or four different subfields to transform raw text into meaningful knowledge. So Modern NLP is using these 3, 4, 5 different subfields to transform. We are using the word transform here, our raw text into meaningful knowledge. Or you can say, in general words, you can say, we are using these 3, 4, 5 different approaches to transform our input to output. This is general way. Huh? Normally, the models that you built by using these 4 approaches, those models will take simple raw text and then it will be converted or translated or transformed into the form which you want. And that is called meaningful knowledge here. These are the general words, but the general meaning is you can convert your input into output. If you want to, if you are not understanding, then you can say input to output. Now, core concepts. So you will see that we were calling something sometimes a document. Then what is a document? You already know. If you have a file and in that file you have a text data, or if in that file you have a speech data, audio data, then now I am focusing on only on textual data. So if you have a text in a file, then you can call that file a document if that file is not that large enough. If it is not a collection of documents, it is just a simple. For example, if you have an email, you can call email a document. If you have an essay about morning walk, that essay is called a document. Similarly, if you have an article, that is called document. So now this is what? This is a one complete unit of text. Same concept you can apply on audio or speech data. Okay, so you don't have to confuse your mind. If you have in a file, you have only one audio song, so you can call it document, but it is the format is audio because conceptually it is a document conceptually. Then there is another term that is called, we will use corpus. Corpus is a single form, and it is a collection of documents, or it is a collection of text, but the size of this corpus normally be larger than a document. It can be collection of documents or it can be one file with a large size. So what is corpus? A large collection of text documents. And we normally use this corpus in our model for its training and then for testing. And then that testing is called evaluating, okay? For the training of the model or for the evaluation of the NLP model, we will use this corpus. Corpus is singular, corpora is plural. When you have multiple, uh, I can say corpuses, but actually the word is corpora. For understanding, I am saying corpuses, but actually the word is corpora. So now the next term is text processing. Text processing. When before that there is a text collection, but I am not mentioning that. Okay, you are collecting data from different sources, So when you have collected that data from different sources, now you are going to perform text processing. And this text processing will do what? It will transform the format or the shape of your data into your desired format and shape. So this text processing will transform raw data, raw or unstructured text. The data that you have collected from different sources, that is called raw data, but it is unstructured. It means that there are many issues in it. Some of the data can contain tables, and some of the data can paragraphs in your file that you have collected, and some of the data can have images in it which you don't want. So these the nature of the data that you have collected is different. So due to these differences, we are calling it unstructured. This is not a structure that you want to give as an input to your model. So then what? Text processing step will transform your raw unstructured text into a clean and structured data or format. So when you will apply the text processing steps, then your data will become clean, and then your data will be in a single format. So that you will call it structured data or structured format. And that would be suitable for your model. And that would be suitable for your computational analysis. So if you will see this diagram, there are different things in text processing. Here, standard text processing pipeline for NLP 1, 2, 3, 4, up to 9. First, you will collect the raw text. And if the raw text is something like that, I cannot present here large amount of data. So here I am taking a simple sentence. I am loving NLP, exclamation symbol, and then there is emoji and pound symbol AI. This is raw text. And if you want to apply text processing, then in text processing, you have these steps: text normalization, tokenization, noise removal, stop word removal, stemming, lemmatization, fi final clean. Okay, this is different. So now 7, 8, 9 is not the part of text processing. But yes, now for these models, for LLMs or something like that, you cannot go on with the text here. LLMs normally not deal with your textual data. When you are doing text processing, and after the text processing, you are converting it into vectors. That is separate discussion. Leave it. So 7, 8, 9, okay, you can ignore them. But the other things are the steps of your text processing. Here, text normalization. If this is the text, in text normalization, what can be the possible steps? One step is you are going to convert all the text into lowercase. Unicode cleanup. If there is a Unicode character used in your text, and if you are handling English data only, then you will have to remove your Unicode characters from your data. Because English characters, you are dealing with the ASCII format. And then expanding contraction. If there is short abbreviations there, then you have to expand it in full. For example, here you have the NLP, then you have to convert it into natural language processing. Similarly, then tokenization. Tokenization is easy. Tokenization means that you have to transform your data or text into words. So then what? I is one word, am is one word, loving is one word, NLP is one word. After transforming it into lowercase, then NLP this form, and then this. These are the separate things here. Now we are removing noise. Uh, I think you have studied machine learning, huh? So most of the people have studied machine learning. So then you have the concept of that noise. So here, what can be the noise here? This exclamation symbols, emojis, this pound symbol or hash symbol. These can be the noisy attributions. So we can remove them. So noise removal in this step, what do you normally do? You normally remove punctuation, you normally remove emojis, some special characters or the URLs. For example, www.nlp.com is written there. This is URL, huh? So you have to remove it. So in this step, you have to remove this is called noise removal. Stop word removals. The frequent words in any language are called stop words. So for example, in English, we are removing am, the, is. These are very much frequent. The frequency of these words in the data is quite high than the others. So So we are removing these. The other concept is we are removing these frequent words. Moreover, their contribution towards the meaning is also less. So that's why we are removing these. And then finally, we will have I loving NLP AI is remaining from your input data. And then stemming or lemmatization, okay. So here I NLP AI, no, but this loving, uh, we are applying this stemming or lemmatization step here, and then loving will be changed to love. And finally, our clean tokens will have what? Love, NLP, and AI left after text processing. After text pre-processing, final clean tokens are left with these options only. Other things are removed. Now, so now tokenization. So now you know what is tokenization. Normally, token means word in a sentence. So tokenization is then what? Tokenization is then what? Process of breaking down a sentence or a text into smaller units, and those smaller units are called tokens or words. Or breaking a sentence into words is called tokenization. Breaking a sentence into words is called what? Tokenization. This is simple in your own words. There are other concepts. Okay, breaking a sentence into words is tokenization, but sometimes you are breaking the words in a sentence in syllables, or sometimes you are breaking the words in a sentence into letters. Letters are, for example, in English, A, B, C are letters. So you are not focusing on words, but you are focusing on characters, letters, and separating the letters. You can also do the tokenization with respect to letters, and you can also do the tokenization with respect to syllables. Syllable is what? For example, uh, uh, for example, the word maktaba in Arabic. You can take any word. And this maktab, you are starting, pausing, and then you are saying the next part of the word. So mak, here I'm pausing, huh? Tab. So there are two syllables in this word. In this word, there are two syllables because you are pausing one time and then you have two parts. So mak, pause, tab. And there are two parts in it. Similarly, you can take some other words. I am trying to get simple word. Yes. Okay. Okay, laptop. If you want to take laptop, okay, huh? So p, to, p, huh? Le, p, to, p, huh? So, p, to, p. So then how many parts? Four parts. So then there are four syllables in it. This is what syllable means, huh? Now, and here I'm just giving examples that nowadays the transformers which we are using in LLMs, so these transformers are using tokenization also there. Tokenization is there. But these transformers are using subword tokenization. Subword tokenization. Subword, what is subword tokenization? This is not the discussion here, but we want to get an idea. Subword tokenization. What is that subword tokenization? There is an algorithm that is called BPE algorithm. Byte pair encoding. And that is the tokenization algorithm that these transformers are using. But the idea in this algorithm is they are doing subword tokenization. And those subword, so word and subword, it means subword would be the part of that word, huh? From its name, the part of that word. For example, here, this is just an idea. Sorry. If this is a word, lower, then BPE will do what? It will make pairs LO, OW, WE, ER. And then in the whole corpus, it will calculate the frequency of these pairs. For example, the pair ER has this frequency 8432 or OW has this frequency and similarly others. But for example, if ER has the highest frequency, if this pair has the highest frequency, then this BPE algorithm will do what? It will merge these two characters with each other. And then in the step 2, you will have this situation, low and the ER, because ER has the higher frequency. And then it will see again which next pair has the highest frequency. And if OW has the highest frequency, it will merge them. And then this would be the situation, OWER. And then it will check next, which next pair. For example, LOW, it is making a pair, and then low, it has this frequency. And for example, WER has this. So low has higher, and then it will merge. It will keep on merging that like that along with the frequency. What is the benefit of this thing? What is the benefit of this thing? The algorithm will, it can detect suffixes, pre-suffixes, frequent words, and code patterns without any rules. This algorithm can do what? Then this algorithm can detect suffixes, pre-suffixes, frequent words, or code patterns from your corpus without any rules. It will do it automatically. What is suffixes? In English, some things which are coming at the end of any other word, for example, ing, playing, ing. Huh? So this ing or these other forms, these are called suffixes, which are coming at the end of the word. Prefixes which are coming in the beginning of the word, like this, un, re, pre, dis, sub. So it can extract these suffixes and prefixes automatically without any rules. You don't have to code any rule, okay? It will extract automatically because these prefixes and suffixes will have the higher frequency than others, huh? What is the reason? Because these words we are using ing, we are using ing, shen, ness, iti, mint, id, li more frequently than others. And then algorithm will calculate their frequency and it will automatically detect those things. And if you are going to perform lemmatization and stemming, then here this BPE algorithm is giving you that information. Remove this suffixes, remove this prefix, and then you will have your lemma. Or then you will have your stem. Frequent words, okay. So this BPE is also giving you the most frequent words. It is highlighting frequent words, and then you can remove those frequent words, huh? Words, not pairs, okay? If you are going to remove stop word means frequent words. And then code patterns. If you have something like that in your text, for example, it is a Python text, then def, import, return, class. These are some reserved words, code patterns. And if your data will have these things there, if your data is about programming language data or programs, then you can detect these things also by using this BPE algorithm. Yes.
Accuracy is low because I mean there is no showing the present simple, the past simple. So the words it's becoming the same. For for example, play, play, play. The first one is play. The second one is play. So is this make any problems for the accuracy later for training the model itself?
For example, if playing and play after removal, so then ed and ing is something the suffixes. And if you want to remove that, it can remove. If you need it, it can remove. Now, if the question is accuracy, yes, there are different models. Some models have better accuracy than others. And this is existing. This is existing around us. And then people are handling these accuracy issues with other approaches also. They are, if they are using only this algorithm, and if they are not getting state of the art accuracy. State of the art accuracy means if some person already came up with some idea and his accuracy is 96%, and now you are building your model with this algorithm and your accuracy is 94, then your accuracy is not the state of the art. So now you will do what? You will do something more in your model to make your accuracy more than 96. And this is how people are doing research around us. So if the question is that accuracy can be disturbed or not, okay, yes, it is. And that is how people are doing better and better and better. Hmm?
So what the value of merging or what removing these uh, more words or more different? What different? I mean,
Because machine learning models works better with short forms. If you will run your machine learning model with the data that you have as it is, you can get the results. But if you run your models with the short forms, you are you can also get the results. But according to the research, short forms are giving you better result than your complete forms. That is that's why people are trying to remove these things in the pre-processing step. Okay, so this question can come in your minds that why not we will go with the data that we have collected. Okay, you can go on and then you will see your results will not be better. But if you will pre-process them, then you will see that your model will take less time, it would be efficient, and it will give you better results. Hmm? Clear? Okay. And this picture is just giving you an idea that you are collecting your data from different sources and then you are finally getting a corpus, huh? Nothing else. Now, sentence segmentation. Sentence segmentation. The word segmentation means dividing something into pieces. And now, sentence segmentation means you are dividing your corpus into sentences. So this is the definition now. You are dividing your document into sentences. And now here you can see a simple picture. So this is your corpus. And then based on this full stop or period, then this is your one sentence, two, three. This is chunk one, two, three. And the result is this is first sentence, comma, second. So you are separating. You are separating. And then you can, in one file, you can place your one sentence in one line. In the next line, you can have another sentence. In the next line, you can have another sentence. If you are doing something, it's better to keep one sentence in one line. Now, normalization. So normalization have different things in it. So by applying this normalization, you normally convert your text into a uh, unique or same format or consistent format. Huh? Through this normalization, you normally remove different issues in your text, and then you align your text into the same format, consistent format. Consistent means something similar. For example, here in normalization, you can apply lower casing, you can remove punctuation, you can expand contractions. We already have seen in the first diagram. We already have seen this in the first diagram. And when you apply this normalization step over your text, then it will do what? It will reduce the vocabulary. It will reduce the vocabulary size. Vocabulary normally means that, okay, this is a file, and in this file, you will have different words, unique words. Vocabulary normally means from your text, you will extract unique words. If one word is repeating, you will not repeat it in the vocabulary. Okay. And then stop word removal. We know that the frequent words which are occurring in our text, we want to remove them. We want to remove the frequent words. Why? Because mostly they are contributing little meaning or little semantic meaning. Semantic also means meaning. Okay. So I can say that we want to remove these frequent words because they are contributing little semantics. So let's see if I have some. So if this is a sentence, we are applying normalization, and then Gina went back. This university U is now become lowercase. Tokenization, okay, word separated. Stop word removal, stop word, frequent word, back and to are removed. And then stem and lemmatization, Gina is a proper noun, so there is no stem or lemmatization with it. Normally, it is with the verbs or the nouns if nouns have different forms. For example, went, the initial root form is go, so that's why it is converted into, transformed into this form. University is only to universe. Anyhow, coming back. Now, moving next here, lexical analysis. The term is lexical analysis. If I say this is a lexical item, it means I am talking about a word. Lexical item means a word. So, what is lexical analysis? When you are analyzing a word, huh? And what is in it? This is called lexical analysis. So, this in this lexical analysis studies this step studies individual words in your corpus, individual words in your corpus, and it will study their morphological structure. Morphological structure normally means, for example, if the word is playing, sorry, I am using mouse here, so my writing you will not understand easily. So here, if the word is playing, then you can say this play is the root, and this ing is the gerund form, a progressive form, and it is representing continuous tense. You are giving extra information about the different parts of the words. And if you are giving this information about the different parts of the words, this is what? This is called morphological analysis. This is called morphological analysis. Normally, morph means shape. Hmm? Shape. A morphological analysis of a word means you are discussing different shapes of the word, different forms of the verbs, of the word. So then lexical analysis, this will do what? It will study individual words and their morphological structure. You will see in this analysis, you will see how these words are forming from different parts, how these words are building from different parts, and what is their grammatical structure. For example, here grammatical structure is, it is gerund form. It is progressive. Gerund means progressive, continuous tense. And if it is ed, then I can say that it has the past tense. This is its grammar, huh? And here formation or root first, and then it is we are using a suffix here. So now these things are clear. Clear or not? Raise your hands. How many of you understood this? Okay. Where we are using this lexical analysis? We are using this lexical analysis if you are going to build a spell checking application, spelling checker, huh? Then you have to do this. If you are going to build some application for text normalization, then you have to do this. If you are building a search engine, these are only 3 examples. We can go on with many examples here. If you are going to build a search engine, then you have to do this. Similarly, stemming. Okay. Maybe the people who have studied machine learning with me, they already know stemming there, because I think I have discussed this there. So stemming. Stemming and lemmatization are very close concepts to each other, but there is a minor difference. Stemming will do what? It will remove suffixes. And now, what is suffix? At the end of the word. Something at the end of the word, huh? So stemming removes suffixes, remove suffixes to get the root word from it. I'm using the word root word. I will use this root word also for stemming, and I will use this word also for lemmatization. But when I will present the definition of lemmatization, I will add something extra. So stemming. So you are removing suffixes from the word, and you are finally extracting or getting root word. Sometime you will get this root word after performing this stemming. Sometime you will get this root word without semantics. Sorry, this is the word semantic. So sometime after stemming, you will get something which you can call it a root, but you will get it without semantic, because that word will not exist in English vocabulary. Lemmatization is also the same thing. After applying lemmatization, you will get a word to its root form, but it will always have the semantics. That is the only difference. That is the only difference. Now, for example, here, now you will get another term, affix. What is affixes? Affixes has both the concept of suffixes and the prefixes in it. Okay. So affixes are what? Bound morphemes which attach to roots or stem. So you have a root, and if something is attached after or before, you can call them affixes to get as a common concept. But if you want to separate it, if something is after the root, then you can call it suffix. If it is before the root, then you can call it prefix. But if I'm saying it, I have an affix in this word. If somebody is saying this, he's saying true. He's saying the truth. So, for example, here, natural. So nature plus al, this is suffix here, but I can also call it affix. Similarly here, unnatural. The word is unnatural. This un is pre, this al is suffix, and natural is now in the middle. The other thing is when one word is bounded by two things, prefix and suffix, then you can call it an affix. Okay, clear? Then it is better to call it affix. If it is something coming only at the end of the word, then you can call it suffix. Then, then there is no need to create a confusion that you can call it affix. Okay, something before you can call it prefix. But if some word is bounded between two things, then you can call it affix. Okay. What is stem? Stem is also a root. What is lemma? Lemma is also a root. But lemma has meaning, stem has sometimes no meaning. Stem can have a meaning or sometimes not. Lemma always have the meaning. For example, here, unnatural, this is prefix, this is suffix, I can call it affix. And what is the stem then? This green one is the stem. Similarly, now here, unnatural, naturalistic, naturalist, naturalism, you have different things. And these, the green one is what? You can call it stem. Hmm? And if you will say nature, then this is what? If you call this nature, natur, this is a root, but no meaning, not existing in English. And but if you call it nature, this is a root and it has the meaning. So now this is lemma. This is stem. Hmm? Okay. Understood? Okay. Moving next. You can also see it from here. Stemming is what? Developing, development. So then these suffixes will be removed. There is a stemmer that is called Porter stemmer. This is an application. You can use them when you will code things in Python. You will use this Porter stemmer there for the stemming, and then it will do what? It will remove these things and it will give you this develop. So this is stem. This is what? Stem. And lemmatization, drives, drove, driven. You can use WordNet Lemmatizer. This is an application available as a library in Python. You can use it and then it will give you what? The lemma, which will have the meaning. Which will have the meaning. So this is now the lemma. Hmm.
Studying or words that do study, you see this word becomes understandable. For example, because develop, it's showing its name.
Hmm.
Even if we are targeting the develop for developing, the result is a word.
Hmm. Yes, this is what I said. In the stem, yeah, sometime you will not get semantics, okay? But in lemmatization, you will always get semantics, okay? You will always get semantics. But in stemming, sometime you will lose semantics. And what you will get finally, that would be called stem. Okay, next. Part of speech tagging. There is a separate chapter in the book, in your book, on the part of speech tagging because this is an important topic. But I skipped this. Okay. It's not that difficult actually. It's easy. But there is a separate chapter. Part of speech tagging or part of speech labeling. Every language normally have these classes in it. Now, what is noun? What is adjective? What is verb? Hmm? Uh, you have these classes. What is preposition? You have these classes in Arabic, in English, in Urdu, whatever. So these classes are called part of speech. You can call it classes or categories. These are the things which are available in each language, due to which you can call that this word is lying, this word is a noun, this word is a verb. You are giving class to that word, you are giving categories to that word. Why? Because these part of speech categories are existing in languages. And these part of speech tagging can do what? It can assign grammatical role to the word. When you are saying this word is a noun, you are assigning grammatical role to that word. When you are saying this word is adjective, you are assigning grammatical role to that word, and you are also getting semantics. Where we are using this? We are using it in parsing. We are using it in information extraction, information retrieval. We are using it in translation, machine translation. And I said there is a separate chapter on it. And there are different algorithms for it, for doing part of speech tagging. But I skipped from your course because it's easy. What is this? First see all these, and then I will come to these pictures. And this is the picture for the part of speech tagging. And then named and okay, have a look on that. For example, the sentence is this post is about text analysis. This is the sentence. And then this is what? It is adjective. ADJ mean adjective. This adjective is now a tag for this word, label for this word. And then post, in this word, this post is a noun. And then is a verb. About is a preposition or preposition. And then text is a noun in this word. Analysis is a noun. And then dot is what? Punctuation symbol. Punct. So this is now tag. This is now tag. Or you can make it more short. Noun as only N. Verb as only V. You can make it more short. Huh? You can define your own tags, and then you can build a program, and that program will then take input, raw text, and then your program will apply the tags on in on or in the words in your file, in your corpus. It will apply the tags that you have designed, and it will give you final output, the text with the tags. This program is now called part of speech tagger. Tagger. Hmm? And there are different algorithms. Some algorithms are simply rule based, some are statistical. Now, next, named entity recognition. Named entity recognition is not machine learning, okay? Even people are using in machine learning. People in the machine learning and even the deep learning, now people cannot identify what is machine learning, what is deep learning, what is NLP. Huh? Only NLP guy can tell you what is machine learning, what is deep learning, and what is NLP. For example, the persons who are studying only machine learning, they don't know the other knowledge. Huh? They only know that chapter of machine learning, one or two chapters in the NLP book. Anyhow, now named entity recognition. Named entity. So you have to recognize or you have to identify named entities from your text. The words which have a concept of name, either a simple noun or a proper noun, means name of some person, name of some location, or name of anything important, So if you want to identify these things from your corpus, this is called named entity recognition. So identifying important entities in text, this is called named entity recognition. And these important things can, where we are using this approach, we are using this approach in resume analysis, CV analysis. Algorithms are automatically analyzing your CVs and selecting better from it and presenting it to the boss. And then in medical reports, identifying different things from the medical reports and presenting it to the doctor for further analysis. Questioning answer, simple questioning answer application. You are doing question, it is giving you the answers. And we are using this NAIR approach there. How it will work? Let's see this. You have unstructured text first, and this is just a story. You can see here some Dr. Ania Sharma, University of Oxford, London project. I have highlighted these words only for your understanding. Otherwise, in a text, these are not highlighted. So in this unstructured text, you have some person names, you have some organization names, you have some location names, you have the dates, you have some other miscellaneous information. If you and each of this drawer that you are seeing here, each box that you are seeing here is a named entity, is a named entity. And now you want to extract these named entities from this text. And from this text, for example, here Dr. Ania Sharma is going into this person name. Organization, University of Oxford, location, London, date, this 25, 2023. From this text, miscellaneous project Apollo. So now your named entity recognizer, which is an application, it is recognizing these texts from this unstructured text and putting it there, and finally giving you structured data like that into the form of table or whatever you want to say. Person this, organization this, location this, and so on. So it is keeping your data entity wise. Entity wise, huh? Now, what is parsing? Parsing. Again, this parsing will identify grammatical relationships. Grammatical relationship. What is grammar from here? What is grammar here? Different categories of words, nouns, adjective, verbs, adverbs. So parsing. But this is not the only thing that you can call it. This is grammar, okay? Grammar has many concepts in it. So what is parsing? This process will identify grammatical relationships. And there are two types of parsing. Not two, there are many others, okay? But here we are going to present only two, constituency and dependency. These are the popular one. Constituency parsing is about phrases, noun phrase, adjective phrase. If I say noun phrase, then it means more than one word are combining with each other and giving one concept, and that is making a phrase, huh? And we can call the phrase with another name which is called constituent or constituent. So constituency or constituency or the phrase is same thing. Dependency is something, one word is dependent on another. And if you are identifying these kinds of relation between words, dependent relations, this is called dependency parsing. Where we are using it? We are using it for information extraction. We are using it for chat bots. We are using it in question answering. Here it is a picture I can discuss it further, but when this topic will come, we will go into the details of it. The first picture that the first tree that you are seeing here, this is constituency parsing. And the picture, the tree that you are seeing here, this is dependency parsing. Here you can see if the sentence is the children ate the cake with a spoon, then the children combined word, combined words. And then ate the cake, the and cake are combined words. With a spoon. So with a spoon, actually a spoon is one word or combined word, and then with a spoon, with is also attached with a spoon. So and then this with is also attached with this spoon. You cannot separate this with, and you cannot move this with here. The children ate with the cake. You cannot. You cannot separate this with from here. So you have to think like that, and then you will see that what are the combined words. For example, here the cake, the is determiner in English. This is the tag. This is the part of speech tag for the. And this cake is noun. NN. NN is a tag for noun. Here we are using some other different part of speech tag, in which these tags are available. DT for determiner, noun, NN. And the and cake, they are one word and making a what? Noun phrase. This noun phrase is a constituent. This is what? It is one phrase. It is one constituent. Now, here, a spoon, D, this is determiner, this is noun, and they are making one phrase, noun phrase. And with is attached with this whole thing. A spoon is one word, and with is attached with this whole thing. But with is what? It is a preposition. And we are representing it with JJ. Okay. And then now here, a spoon. Spoon is the main word. Main word. A is attributing. So due to this main word, it is making noun phrase. But here with a spoon. Now with is a main word because a spoon we already handled. And with is now here. And this is the main word now. Due to this, it is making preposition phrase or preposition phrase, PP. This is the tag for it. This is the tag for it. This tag set will be given to you, and then you will see there what is the tag for the preposition, and then you will apply. And now here, the children ate the cake, ate not spoon. So this verb is linked with this thing. So that's why ate is here, and now it is VBD, which means it is a verb, and D means past tense. And this is the tag available there. And then it is making a verb phrase. So this verb phrase is a constituent. This PP is a constituent. This NP is a constituent. This VP is a constituent. And then these two are combining with each other. And this is again in knowledge. How this tree is becoming, this is a different separate story. You have to learn that first, and then you can build this tree. Otherwise, maybe it is difficult for you. So this is a VP. And then the children, this is NP. And finally, these two phrases are going directly to the root of the sentence. So if you have something like that, these phrases NP, VP, PP, these are constituents. And this is called constituency parsing. Yes. Yeah, I know that. Just give me time. I'm finishing this slide and then I will take it. And now this one. Here, this tree is different. This is dependency parsing. This tree is different. Here you have to see that which word are dependent on which word by keeping the main verb of the sentence in your mind. By keeping the main verb of the sentence in your mind. Now, I saw the man with the telescope. Saw is the verb. Now, keeping saw as a root of the sentence, now you have to see what is the subject of this verb. So, I is the subject, noun subject. What is the object of this verb? I saw The man would be the direct object. So here, the man, this is the man, direct object, the object, direct object. And this man has the determiner. So we are saying, we are building this arrow there, that this is the determiner. And what is this? What if you have identified object, if there is some other main concept, you can call them adjunct or modifier. How I can call them adjunct or modifier? This is also a separate story. Okay, you cannot tell them easily. Okay, you can only tell them adjunct or modifier when you will have that knowledge there. So now with this telescope, I know that this is like a preposition, huh? The telescope. So I am now saying that with the telescope, I saw the man with the telescope. It has two meanings, but leave it. Now, telescope is the main thing. So then I'm saying this telescope is a noun modifier, or you can call it adjunct. Adjunct normally means additional information. And then the is the determiner, and this with is case. In Urdu, we have the case markers, or anyhow, you can call it preposition. Huh? Case has a definition, leave it. And now these arrows are showing that which word is dependent on which word. All the words are depending on this sa, but they are also depending on each other. So this has a different formation, which is called dependency. When you will see something like that, you don't have the tags like that, phrases. If you will see something like that, that is dependency parsing. This is constituency parsing. And I will start, inshallah, from syntax semantics next. Huh?